I'm going to present the fourth place solution. My name is Elahi and I have a background in chemical engineering. I used to work in insurance company. And the goal of the competition is to classify the ovarian types. The main challenges in this competition is the whole slide images is very large. We have to select the part region of interest, and the March data is very partially labeled March data is given, and there is unlayer detection. That is, we have to classify even the outlier which is not present in the train data. What I did is, in a nutshell, for detecting the region of interest in the whole slide image, I have used a classification segmentation model to select the pixel with likely having the cancerous data. The segmentation model was trained on thumbnail images, and then the segmentation model trained on the thumbnail images is used to select the tile. Then the classification can be done on the tile. For the DWA tiles images, it is directly, and there is no tile generation. I haven't used any transformer-based models because they are memory, they consume more memory. So I have used only convolution-based models, Convnet, RNet, Efficient Nets version 1 and 2. For segmentation, I have used FPN structure. For the pre-processing, I have used, there are some thumbnail images which are very small. So I have to resize them to like 1500 pixels height. And for TMA, the TMA and WSA have different magnification. So I have to resize them such that they have similar magnification. Initially, I have used segmentation models trained on the supplemental mask data. But the drawback is the only partial data is available, and the labeling also done sparsely. And for predictive probabilities, I have used sigmoid because we have to even predict the probability of the outlier. And segmentation models were trained on both mask prediction and classification tasks. Segmentation models have okay. For the selecting the tile with the most cancerous part in the WSI, I have used convex model. Efficient net model depends on the complete context of the image. If there is, if the tile has more empty field, then it might not detect the small part of the tissue in the tile. Convex doesn't have that problem. It depends only on the local pixels and doesn't depend on the whole context. So I have used convex model to train on thumbnail images to select the tile with most probability of having a cancerous part. And after modeling the segmentation model on the thumbnail images, I have used that model to select the tiles in the remaining WSA images. Classification models use less memory than segmentation models, so I have used larger parameters, models with larger parameters than segmentation models, and I have trained for longer times epochs. For augmentation, image augmentation, for half of the models, I have used stain augmentation, and so, for all, I have used hue, random hue. Hue might work as a stain augmentation, therefore, I have given more importance to hue. And for and the remaining augmentation was scaling, rotating, flipping, and contrast. Here is the summary of my training methodology. The supplemental masks were used to generate segmentation models. They were downsized to 0.5 size. These are for 8 segmentation models, and for thumbnail models, segmentation model, I have used only single prominent model. I have resized all the thumbnail images to 1536 by 1536, and I have trained a single segmentation model. After training that model using thumbnail images with segmentation model on thumbnail size, I have selected a particular pixel with maximum probability of having a cancerous spot, and then I crop the region around that particular pixels. And using those cropped images and TMA images, I have trained classification models. And here, for the training methodology, my training period, I know the class of the cancerous tile. So I select only the tile having the high probability of having that particular cancer. During inference, I would not have that data. During inference, for classifying TMA images, it's straightforward. It's a single image, so it's done directly. For the WSI images, I have used thumbnail images resized to 1536 using the segmentation model trained on thumbnail size, and then I have generated 5 tiles, one for each class. And then I have used classification and both segmentation models and classification models to predict the probabilities, and then I have taken median of the probabilities. For detecting the outliers, I have taken the considered the probabilities less than 0.05 as outliers, and for second method, I have used bottom 10% of the lowest probabilities as outliers. Both have given good results.